About this lesson is that it's day 1 and 2, just with the calculator. You understand day 1 and 2? Great. You'll be fine for this lesson. You just got to be able to use your calculator efficiently, effectively. I'm going to teach you some tricks of the trade. Pay attention to these tricks. They're very useful. A lot of people don't know what I know about these graphing calculators. If you did not understand day 1, day 2, well, this might help you understand it better. Okay? Here's what you have to be able to do in a calculator. You have to solve an equation. How we solve equations. This is one of those lessons where, like, don't write stuff down. Just, like, pay attention, please. And do what I do. How we solve equations is we treat them as two different y equals equations. Okay? We are trying to find the x value when the y's equal each other, when the y equals 2. Great. Everybody knows how to graph using the graphing calculator, correct? Okay, so first things first, probably want to reset everything. Second plus 712 ensures that everything is reset. All of the equations that were in are gone. All of the things that were stored are gone. And we can pop into y equals, we are going to be in a nice standard viewing setting. We graph x to the 5th minus 4x squared. We graph y equals 2. And my friends, this is how we solve equations that we don't know how to solve. We graph and we find the intersection. Okay, now how do you find an intersection? Everybody pay attention. There is this calc. Calc is above trace. It's in blue lettering, or on your calculator it might be different. But if you want to access the blue lettering, you press the second button to access the extra buttons. You go to second calc, you go to intersect. Intersect. You will tell your graphing calculator that yes, you would like to find the intersection between the first curve and the second curve. You press enter, you press enter, and you press enter. There's more than one intersection. Make sure you go over to set intersection. Mr. Messer. Hi. Yes. Yes, I thought I sent a message back saying that's fine. We are going to get licenses from TI. Well, this is for all math teachers, so like 23 math teachers. Cool, thanks. All right, now, this is your solution. The x coordinate, x equals 1.676. Now, really quickly, and this is one of the Mr. Messner tricks of the calculator trade. Whenever your calculator finds something in the graphing window and you see it on the bottom, whenever you see stuff on the bottom of your graphing window, your calculator has stored those values. Don't believe me? I'll show you. Everybody go into the home screen, do second quit. Okay, this is the home screen. Second quit to go into the home screen. Cool. Now, there is a shortcut for X. X right here. Hopefully you use that instead of alpha X. If you use alpha X, it's fine, but this is a shortcut for X. Press enter after you type in X. What do you notice? That is the X location of your intersection. You now have that number saved for later if you need to use it. You did not find the correct intersection. Go back and do it again. How do you clear? You do second plus 712. Cool. Now, let's say we wanted to use that value and a different value. Another great thing I like to use on the calculator is the trace button. Everybody press the trace button. The trace button is frequently misused. Why do I say the trace button is frequently misused? Because you guys usually just trace over by using the arrows. But what I like to do is, after pressing the trace button, I can type in any X value that I want to find the Y value for. Let's say 1.75. Press enter. You get the Y coordinate at that location. Now again, that is information your calculator just found. Go back into your home screen. Maybe you want to use that Y value later. Well, there it is. Alpha Y, boom. I talk about in the homework video how you can store these values as different letters. Sometimes you're like, hey, I want to use 1.676 a lot. I can take that X and store it. Everybody find the store button. The store button is above the on button. You've never used it before, but it is actually how you like tell your calculator, hey, I want A to be 1.75 from now on. Or I want, say, Y to be B. You could say, take this, and all of a sudden, whenever I choose to use B in any type of setting, like B will be 1.643 until I override it. The one thing worrisome about like using X over and over is like once you've done something, like once I go back in the graph and maybe I do trace and I do 4, like Y is now overwritten. If I go to Y, it'll be 960. Okay, so heads up, just like if you want to store values, great, but they'll always be stored in the home screen if you just like type them in. Cool. So that is a way that we can calculate average rates of change. Watch. We know to find an average rate of change, all we need is 2 points and we need the slope. So I could, if I want to, go into Y equals and do 4.7 divided by X cubed. Again, you should just like pay attention and just like see different ways to do the same thing. And this is one way to do this. This is not the only way. Obviously, you could just plug 1 and 3 into this and get the Y values. But let's say you want to use the graphing calculator's capabilities. You can go trace 1, 4.7. If you want, you could store that value in your home screen just by typing Y. There's 4.7 right there. Graph, trace, 3. 0.1740747. Yeah, instead of writing down that entire decimal, maybe I'll just write a couple just so I know it, but I can go back into my home screen and save the Y. Boom, there's my 2 Y's. I can do Y2 minus Y1. Oh, actually get the fraction button out. Fraction button's the favorite, right? Everybody's favorite. Go to the fraction button, Y2 minus Y1 over X2 minus X1. I can do this without having to like write down the entire decimal. You know, it's like a way for your calculator to easily do that. I just calculated the slope. We're all comfortable calculating slope, right? You can find this value obviously by plugging in 1 here, by plugging in 3 here. This is a different way. But wait, there's more. There's another way to get that negative 2.262, which is our average rate of change. Which is telling me what? Tell your neighbors, what does this tell me? Quick. Review, lesson 1. What does that number tell me? On average. On average, f of x decreases 2.262 y per x, right? We're reviewing. That's what a slope gives you, a rate of change. Cool. Here's another way to get that answer. It's going to blow your mind. Ready? Pay attention. Be focusing. Mind's going to be blown. Fraction button. Cool. Alpha F4 pulls up a list of your equations. Y1 is the equation I entered, 4.7 over x cubed. Using parentheses, 3 actually plugs in 3 into Y1 and gives you the Y value. Minus Y1 with 1 plugged in over 3 minus 1. Bam. If you alpha Y1 and use parentheses, it plugs in the value into you. It's just like using trace. Okay. Cool. So, cool ways of getting values, using those values, using your calculator, new to you probably. Plug in the x into the equation. Yeah, but again, I showed you multiple ways to get that value. You could do y1 of the x, and it'll compute it to you. Well, here's another one. You can graph, press trace, click the x value you want to go to. It plugs it in, gives you the y value. Once it's on the bottom row, it is saved as y until it's changed. So again, if I say plugged in 4.5, and I get 0.015 in my home screen, that's what y is. Okay, cool. Moving on. Sometimes we want to graph functions so you see it and it makes sense in the world and it's not just everything. So everybody watch me. After we graph negative 9.8x squared plus 12x plus 8. Can't really see it. It's not really real world applicable. If I read the situation, we're talking about a ball being thrown off a ladder. So we're probably talking about time starting at 0. We probably just want this path of the ball. I want to get my calculator to give me that graph. What am I going to do? Well, I'm going to adjust my window. First of all, I'm going to kind of approximate where the 0 is located. We're going to find the 0 in just a second. It's around 1.7. Okay, so I'm going to adjust my window and say, you know, I kind of want to start at 0, but to make sure I look at what's going on at 0, I'm going to start at like negative 0.5. That's where my time's going to start. And I'm going to go to like around 2 seconds because I can see my zeros right around 1.5. Cool? Now, that adjusts your x's, but my y's are still a little bit finicky. Now, I can adjust my y's if I wanted to in my window, but here's another Mr. Messner, like, calculator secret. When you adjust your x's and you want your y's to be adjusted automatically, go to Zoom Fit. When you go to Zoom Fit, your calculator will automatically adjust your y's based on your x interval you selected. This allows you to see that maximum. This allows you to see like all of the graphs based on the x's that you selected. This looks great. Cool. So Zoom Fit is a beautiful thing to use in your calculator. So that's what we can do. We got our window to adjust x's, and we got Zoom Fit to adjust y's. And now I have a nice looking graph. But to really understand what's going on, I'm probably going to want to find this location where we have this maximum. like where is the maximum, what's its location, I'm probably going to want to find this location where we have a 0, where we like hit the ground. Okay, so let's talk about finding both of those. Let's start with the max. How do you find the max? Well, second, calc. Look at that, max. Now, go down to max. This might not be new to you. But once you press max, your calculator asks you a question, left bound. Again, your calculator needs a little bit of direction. It needs a little bit of help. You need to tell it, hey, my maximum is right here. Look in between here. So go to the left of your max, press enter. It sets a little arrow up saying, okay, I'm going to look to the right of there. And then it says right bound. You go to the right of your max. You press enter. You ask your calculator to guess. Make sure you get to that point where you ask your calculator to guess, and boom, you find your maximum. 0.6122, 11.673. Maybe I'm going to use those values again. So at minimum, go into your home screen, press X, press Y, and those values are at least in your home screen. If you want to store them as a different letter, go ahead. Cool. Questions? Negative 9.8 x squared plus 12t plus 8. Just make sure you have the negative. Is your window different than mine, McCarty? That's probably it. So I adjusted my window, McCarty, to negative 0.5 to 2, and then I adjusted my y's by pressing zoom fit. Okay? Cool. Now, next thing, let's find the 0. Everybody, second calc. Second calc, 0. This is one way to find a 0. It's actually not my preferred way. I'll show you the other way to find my 0. Again, it asks you for a left bound and a right bound. So you're going to go to the left of your 0. Here's my 0. Go to the left of my 0. Enter. Here's my 0. Go to the right of my 0. Enter. Press enter one last time. We get 1.703. And then 1e negative 12. Guys, whenever you see e and then a negative number after it, that's times 10 to the negative whatever power. That's like dividing by 10 that many times. This is your calculator essentially saying, hey, yeah, that's 0. Okay, it's getting really close to 0. It's like very close to 0. If you go and probably in your home screen press Y, I think it might actually give you all the zeros. Now, think of that as 0.000000000. You need 11 zeros, 1, 2. That number is essentially 0. Remember, your calculator just like approximate values. All right, I'm going to go call mom right now. That was a good time. Oh, really? She's here? Cool. All right. So when did the object hit the ground? 1.703 seconds. Moving on. How long did it take to fall from 5 meters to 1 meter? Oh, guys, this is so tough. I got to figure out when my height equals 5 and when my height equals 1. What do I do? We're not going to do it. Just tell me. Plug in 5, plug in 1? Wrong. Can't trace it. That doesn't help me. Y equals 5 and y equals 1. Guys, how do you solve equations? You can graph y equals. You can find the intersection. Boom. Enter, enter, enter. Save that x. 1.437. That's my first time. Graph y equals 1. Find the intersection when my height is 1. Second calc intersect. Enter, enter, enter. Make sure if you have two intersections that you're closer to the other one.
Which one do we take that versus?
Well, let's think about real world situation. Time is our x's, height is our y. So we want to start at a time of 0, typically. 1.655, I'm going to store that value in my home screen. Boom. Once you have those values stored, you can subtract them. You get an exact answer, guys. Don't round and use rounded answers to get a final answer. Use exact answers, get a final answer, round your final answer. So my time in between by subtracting these two values is 0.218 seconds. Cool? That is not really a lesson 1, lesson 2 thing. That is more of like a calculator thing where it's like, hey, make sure you can find locations by finding intersections. We found the maximum. We found the maximum. Average rate of change from the maximum to the floor. Let's do that up here because I have everything saved. My y's went from 11.673 down to 0. So that's a negative change. So let's find that 11.673 value. There it is. I'll make that negative. My x's are the 1.703 minus the 0.6122. So this is the top of my fraction. This is my y2 minus my y1. And then in my x2 minus x1, I need, I don't know if this is going to show up where it should, but let's see, 1.703. I didn't save it, but I could have. Again, don't do this. You should be using exact answers. Minus 0.6122. There's the average rate of change, negative 10.7 on average. My height decreased 10.7 meters per second over the interval from the max to when we hit the ground. Cool. Next page. I wish I kept recording during that entire conversation and when I yelled at you guys. Not at you guys, at her. I'm recording that now. Yeah. Okay, this is more of day 2 stuff. Here we go. Y equals, type it in, x to the 4th minus 14 x cubed. Man, who came up with this equation? I did. Plus 68 x squared minus 136x plus 96. Great. Now, I don't know what to expect with this. Okay? So what I'm going to start with is a standard window. That negative 10 to 10 window. Heads up. Zoom standard can take a wacky window and bring it back to your normal negative 10 to 10 setting, which we all know and love, which sometimes students used to like reset their calculators to find. Oh yeah, that's nice. Let's get rid of this one. I mean, I feel like I see what I need to see. We're going to talk more about polynomials next unit. An x to the 4th has this end behavior. You guys remember that? Negative x to the 4th would be like this. So I can see these. I can see that I'm going to have, 4 solutions. I can see 3 turning points. Like, I see what I want to see. We're good. Cool. Finding minimum. All right, I can find a minimum. Let's go. Second calc. Min. Can you what? Zoom standard. Go to the left. Go to the right. Bam. Cool. Like, boom, I just found them in. I'll store those in the home screen if I wanted to. 5.28, negative 9.91. You could store those in the home screen if you wanted to, if we needed to use them later. Probably is safe to do it. I mean, if you're used to it, if you're good with it, like, boom, save that X, save that Y. Maybe we'll need them later. I don't know. Good with that. Find the average rate of change. Which way would you like to find the average rate of change? I don't know. It's up to you. Probably not plugging in 1 and 1.5 into this. Either I'm using trace, but like those numbers aren't that bad. I can do 2.8125 minus what was 1, 15 over 1.5 minus 1. You could do that. You could also do, what was the new trick we learned? Alpha F4 Y1 of 1.5, as long as you put fractions. Parentheses, yeah, not fractions. Minus alpha Y1 of 1 over 1.5 minus 1. Boom. On average, I'm going down 24 Ys per X from 1 to 1.5. Cool? Nothing crazy? When is F less than 0? That's when F is negative. Guess what? You're going to have to go in. Oh, I hate when that happens. And find your zeros. Let me show you the other way to find zeros. Hold on, we're going to get to the fun stuff later. This is very much like your quiz. Now, I can see my function is negative in this region. Don't use trace. You want to find the exact values. Now, here's an easy way to find zeros. Everybody, graph y equals 0. When you graph y equals 0, if you have a nice color calculator, you can see the red line, y equals 0. Okay? Now that you've graphed that red line, you can calculate the intersection. I just went to intersections. I'm going to find this first intersection. Enter, enter, enter. Okay? Starting at 4. And then I'll find the other intersection. This is when my function will be negative. 6. Look at that. That's nice. Tell your neighbors, how can you answer the next question? When is my function increasing? What do you have to do to find when the function is increasing? You guys are out of it. Come on, get back in it. When is the function increasing? You typed it wrong. 68 squared. X squared.
When I do the find whatever intersection I
Nice. Good thing to see. Now watch this. Watch this. Watch this. Bus just showed something. Let's run over to this intersection over here because it looks like we had an intersection over here too. She pressed enter, enter, enter. Boom. Got 1.999999988. You got that? Mm-hmm. Right. Guys, you got to understand that your calculator does the best that it can. And when it gets really, really close to something, it's like, all right, that's it. Guess what happened here? My calculator got a value very close to 0, plugging in 1.9999988. Okay? It's your calculator's way of saying, hey, maybe the intersection's actually at 2. If you plugged in 2, you would get 0 bucks. Sometimes this is the same thing with 1e negative 12. Your calculator wanted to say 0, but it was so close to 0 it just stopped. And it put 1e negative 12. You got 1.99998. Just go ahead and assume that it's 2, especially in this class when we want answers to be whole numbers a lot of the time because they're easy to create. Cool? So 2, 0 is the location of a min. We got to find the location of the max. Who found the location of the max? What'd you find, McCarty? 3.219. So there's my first interval from a minimum to a maximum. You had to find that max location to see when you're increasing. Oh, that's a min. Second calc. Max. To the left of my max, to the right of my max. You guys will need to do this. 3.219. Cool? Now, is there another interval? Yes. From our minimum to infinity, you have to find the minimum's location. We already found the minimum's location. The minimum's location was 5.28 or something. To infinity. Okay? Cool. What if I ask you when the rates of change are negative? You find when f is decreasing. It is just the same questions that we had on our quiz today, only you might have to do a little bit of work. We're going to have to go from negative infinity to 2, from 3.219 to 5.281. Boom. It's the same thing, only like our answers involve some decimals and we're finding the decimals. Are we cool with this? Great. How many points of inflection do we have? 2? Let's see. Concave up. Boom, point of inflection probably right here. Concave down. Boom, point of inflection right there. Concave up. Nailed it. You said 2. Nailed it. Can we find the points of inflection with our calculator? Let's see. Second, calc. Points of inflection. You will learn how to find points of inflection when you get to calculus next year. But for you pre-calculus students, you cannot find points of inflection using a calculator. There's no points of inflection button. When you learn how to take derivatives and you learn about instantaneous rates of change, you will be ready to find locations of points of inflection.
That sounds so fun.
It's all just slopes, Linder. It's all just slopes. This unit is very calculusy. All right, skip this. It's all the same. I mean, if you know how to find a max, Rory, a min, you know how to find a 0. If you know how to graph, this, it's all the same. If you know how to find intersections, it's all the same, okay? We don't have time. There are some really fun questions on the AP Pre-Calculus exam that challenge you to understand graph shapes based on hypothetical situations, okay? Who's got their water bottle? Who's got a water bottle? Alan, does he have a water bottle? Sweet. Cool. That's good. Anybody else have a different water bottle? Who's got a water bottle? Oh, yeah, good water bottle, Walsh. Great. Oh, yeah, another nice water bottle. Excellent. Okay. We go to the cafeteria. And somewhere in this building, Oh, I think it's in the link. You have the water bottle fillers, like 3 in a row next to each other. Okay? When you put your water bottle in the water bottle filler, the rate, the water is consistent. Okay? It goes in the water at a consistent rate. Imagine me putting all 3 of these water bottles into the water bottle filler at the same time. Would they all fill up in the same rate? Would they all get to the top at the same time? Would they all fill up at the same time where it's like, oh, they're all like filling up until they get to the top? Tell your neighbors, what do you think? Who's going to get to the top first? Whichever one's the skinniest. So Woods wins. Woods wins because he has the skinniest water bottle. Ooh, this guy, what is going on? The bottom's going to fill up really quickly, right? Because it's nice and skinny. But then we're going to slow down because it gets wider. So I think you're going to win. You're probably going to be second, Walsh. Okay? Alan, you got a wide water bottle. It's going to start filling up, but slowly. So the depth is going to increase, but slowly. So boom, at the top, we get skinnier. And when it gets skinnier, boom, that top is going to fill up really quickly. You got to pull it out really quick once you get close to the top, right? Okay. Consistent rate, but slow. Consistent rate, but fast. What if I had the craziest water bottle in the world that was shaped like this? That was really wide on the bottom, but kind of curved up to the middle. How would the depth change? What kind of graph would that make? If my water bottle looked like this, I would be slow and consistent. This is part 1. I'm going to say that's part 1. Then, all of a sudden, it would start speeding up. What kind of graph would that create if we're speeding up? Concave up. Yo, G Ford is representing. If we have this wider to skinnier, we're going to go slow to fast. Slow to fast, we're concave up. Boom, this is part 2 right here. That's part 2 right there. And then we will finish up going really quickly up, faster up, but consistently. It's just shapes, it's just graph, it's just concavity. All right, try this one. Try this one. Slowly rising, faster rising, slower rising. It is not consistent. It's going to be curved. Yes, so that's the first thing is it's curved. Let's split this into a half. Here's my first half. Here's my second half. Here's what I'm going to say. I am speeding up. This is part 1. And then I need to slow down. That's part 2. This is backward colored. Cool? This one, what's that one going to look like? What's that one going to look like? Nancy, what's that one going to look like? What's that look like? It's skinny, which means it's going to increase really quickly, and then it will start to slow down. Okay? It's just graphs. It should make sense. And that, my friends, is lesson 3, and that's unit 1, really. If you can do lesson 1 and lesson 2, you're good for lesson 3.
Native